Hello students, I am confident that you watched and understood chapter 1 of Form 1 syllabus, that is Introduction to Physics. If you did not manage to watch, kindly go back and check it so that we can move forward together. Also make sure to subscribe, like and comment your concerns in the comment section. Today I'm going to give you a complete and comprehensive summary of chapter 2, that is Measurement 1. Now let us look at the definition of the term measurement. What is measurement? Measurement refers to the process of finding the size of a physical quantity. It is also the process of associating numbers with the physical quantities. The International System of Units, that is the SI units, is a standardized system used to measure quantities internationally. It includes the 7 basic units that we are going to discuss shortly. So the scientists all over the world have one international system of units for physical quantities. There are so many reasons why the scientists decided to establish the SI units. One of the reasons is to have international uniformity among scientists, and also to avoid confusion among scientists. So let us look at the types of physical quantities. There are 2 major types of physical quantities. The first one is the basic physical quantities. The basic physical quantities, abbreviated as BPQ. The basic physical quantities are quantities that cannot be derived from any other physical quantities. The next one is the derived quantities. Derived quantities are quantities that are obtained from multiplication or division of the basic physical quantities. For instance, we have length as the basic physical quantities. If we want to calculate the area, we multiply length times length, so it is multiplication of the basic physical quantities. Also, if we want to calculate the density, we divide by mass divided by volume, so it has involved division and multiplication of the basic physical quantities. Basically, there are 7 basic physical quantities. Now let us look at the 7 basic physical quantities. So the table below shows the basic physical quantities. In the first section we have the basic physical quantity. The next section we have the SI unit and the symbol. So when you are asked about the SI unit, you write the word, but when you are asked about the symbol, you write the symbol only. So the first one is length, the SI unit is meter, and the symbol is small m. So do not write capital M when you are referring to length. The second one is mass. The mass is measured in kilograms, that is the SI unit, and the symbol is small k and small g. The third basic physical quantity is time. Time is measured in seconds, and the symbol is small s. The next one is electrical current. The electric current is measured in amperes, and the symbol is capital M. You are going to do it later at the end of this syllabus, that is cells and simple circuits. Also, another one is thermodynamic temperature. The SI unit is Kelvin, and the symbol is capital K. Luminous intensity, amount of substance, which is measured in moles. That one, going to do it in chemistry, form 3. So those are the 7 basic physical quantities. But if we multiply or divide those basic physical quantities, we find the derived quantities. For example, the area is calculated by multiplication of length. So as we said, derived quantities are quantities that are obtained from multiplication or division of the basic physical quantities. Examples include the area, volume, density, momentum, and work. So momentum is found by calculating multiplying the mass of an object times the velocity. So momentum is represented by capital P and is calculated by mass times velocity, and the work is calculated by multiplying the force and the distance, and distance is a special type of length. So measurement of length. What is length? Measuring length is essential for various practical reasons in our daily lives and scientific endeavors. Length is the measure of distance between 2 points in space. So we have one point and the other. The distance between the 2 points is the length. There are different types of length. So the first one is breadth, the diameter. If you have a cylinder, the distance between one point and the other on the cross-sectional area is the diameter. The height is the vertical distance, and the depth also is a vertical distance but going downwards. The diameter is usually the horizontal distance. So length can be there are other units apart from the SI unit, which is meters. There are other units that can be used to measure length based on the distance. So if the distance is very large, we cannot use meters, we use kilometers. So, and it is important for a student to know how many meters make 1 kilometer and how many meters make 1 hectometer and the rest. So you can see 1 kilometer is equal to 1,000 meters. So kilometer is used to measure very long distances. And also we have another unit, that is hectometer. 1 hectometer equals to 100 meters. 1 decameter is equals to 10 meters. 1 meter is equals to 10 decimeters. 1 meter is equals to 100 centimeters. Now centimeters are used to measure smaller lengths, and 1 meter is equals to 1,000 millimeters. So those are the multiples and submultiples of length. So there are basically two methods that we can use to measure length. The first one is estimation. The estimation is a method that is used when the accurate measures are not required. And also we can accurately measure length using suitable instruments. So some of the suitable instruments that can be used to measure the accurate length include a meter rule that is used to measure distance from one point to another, and used to measure the height of a person, for example the height of a teacher. We have another one, that is the vernier calipers. We are going to do it at Form 2. So the vernier calipers and the micrometer screw gauge are used to measure very small distances. The micrometer screw gauge measures smaller distances compared to the vernier calipers. So these are the instruments that are used to measure the accurate, that are used to give the accurate measures. So while choosing the appropriate method of measurement, there are a number of factors that a student should consider when choosing an instrument. We have said that the vernier calipers measures smaller distances, where the meter rule can measure larger distance. So to choose whether to use a meter rule or the vernier calipers, there are a number of factors that are supposed to be considered. So the two factors include the size of the object to be measured. If the object is large, we can use the meter rule to measure the distance. However, if the object is small, for example a piece of thread, we cannot use a meter rule to measure a piece of thread, but we can use a vernier calipers or a micrometer screw gauge. Important, we can use the micrometer screw gauge to measure the diameter of the thread, and this will give us the accurate results. The second factor is the level of accuracy required. Now the second factor is the level of accuracy required. If very accurate measurements are required, we use the instruments such as the micrometer screw gauge. However, if if the level of accuracy is not required, we can use even the estimation method, because estimation method is just used to give a quick assessment of the quantities. Now let us look at the meter rule. A meter rule is a measuring instrument commonly used for measuring lengths. Meter rules are especially useful for measuring lengths with a reasonable level of accuracy in a situation where specialized instruments may not be required. So the meter rule is graduated in centimeters and millimeters. The smallest division on a meter rule is 1 millimeter. So if you have a meter rule, you can look at it and see the divisions. So you see that after the 10 divisions we have 1 centimeter, and after another 10 divisions we have another centimeter. So one of the divisions is 1 millimeter, and that one is the smallest count on the meter rule, which is the accuracy of the meter rule. If we convert 1 millimeters to meters, we get it is 0.01 meter. This means that if you are taking a reading from the meter rule, your answer should be equal to the 2 decimal places, because the least count or the level of accuracy of the meter rule is 0.01. Now let us look at the procedure followed when using a meter rule. A meter rule has 100 centimeter divisions. We have 1 up to 100 centimeters, but also we have the divisions. We have 1,000 divisions on a meter rule, that is millimeters, that is equal to 1 meter. Remember, 1,000 millimeters is equal to 1 meter. So there are rules to be followed if you want to take the accurate reading on the meter rule. The first procedure is to place the meter rule in contact with the object whose length is to be measured. So you must ensure that the meter rule is in contact. It should not be far from the object, because if it is far, there are other factors that can make you not to obtain the actual reading. So you must place the meter rule in contact with the object to be measured. The next procedure is to place the end of the object against the 0 mark of the scale. So if you look at your meter rule, there is a starting point from the 0 to 1 centimeter. So at the 0 point is where you place at the beginning of the object for you to get the accurate reading. The third one is to position your eye perpendicularly above the scale. So you must, when you are taking the reading, after placing the meter rule in contact with the object, and after placing the end of the object against the 0 mark, now it's time to take the reading. You must make sure that your eyes, the distance between your eyes and the meter rule is very perpendicular to obtain the accurate reading. So the image below is a typical example of how you should take reading. If you check this is the eye, it is not perpendicular. Therefore, there are high chances that this person is going to make incorrect readings. The same case applies to this one. It is not also perpendicular. But if you look at this central one, it is just direct to the division, to the last division of the measurement. This means that this person is going to make the accurate reading. So let us look at the next concept of measurement, that is measuring curved lengths. So it is not always that the measurement we take are straight, that the objects we take measurements are straight. Some objects like the cylinder are curved. So how can we be able to measure the circumference of that cylinder? We cannot use the meter rule, because the meter rule cannot bend around that cylinder. So how can we be able to measure the distance from one point to the other around the cylinder? So to measure curved lengths such as rays and rods on maps, another example is a cylinder. A thread is placed along the required length The length is then found by placing the thread on a millimeter scale. So you wrap the thread around the cylinder from one point. You mark the beginning of the thread and place the initial part of the thread. Then you curve that thread around the object to be measured and mark the final point. Then you place the thread across the meter rule, along the meter rule, and read the reading. So that reading you make is the distance, or is the circumference of that object, or is the distance of the curved object. So for curved objects like a cylinder, a thread is closely wrapped around the surface a number of times. You can choose. You can wrap, keeping in mind that one turn is equal to the circumference. So if you make 2 turns, that is the 2 times the circumference. If you make 3 turns, that is 3 times the circumference. If you make 10 turns, that is 10 times the circumference. So making many turns is important because it helps us to obtain the accurate circumference of the cylinder. So let us do an experiment. The objective of the experiment is to measure the circumference of a measuring cylinder using a thread. So you want to know the circumference of the cylinder using a thread. The apparatus will include 10 milliliters measuring cylinder. You can use any measuring cylinder available. Then a thread and a meter rule. This is the procedure to be followed. Closely wrap a thin thread 10 times around the cylinder. As we have said that making several number of turns improves the accuracy of the readings. The second one is mark with ink the beginning and the end of the turns. So the first point where you started making a turn, you mark it with an ink. Then you wrap to the required number of turns. For instance, for a case it's 10 times. Then you mark the final end, after which you remove the thread and place it along the meter rule and read the reading as R1. Then you repeat 2 times and record the reading as R2 and R3. Remember, R1 is the number of turns, which is 10 turns. That is the length. You divide by 10 turns, because 1 turn is equal to the circumference. We find R1 is the circumference, is the first circumference. Therefore, circumference is found by the number of turns divided by the length measured on the meter rule divided by the number of turns, which is 10 turns. So we do for 2 to 3 times, then that is R2 and R3. Then we find the average length as R1 plus R2 plus R3 divided by 3. This will give us the most accurate length of the circumference of the cylinder. So that is the image. That is the image of the cylinder. As you can see, we have a thread and it is wrapped on the cylinder several times. From the beginning, we mark with the ink, and the end we mark with the ink so that we don't make confusion when making the reading. So the results and the calculation, you can see the average length of 10 turns, that is R is equals to R1 plus R2 plus R3 divided by 3. Then if we divide R divided by 10, we get the circumference. Remember, R is the length of the 10 turns. So to get of the cylinder. So this is an exercise that you may try, and I'm going to give you a hint on how you will solve this question. A length 550 centimeters of a thin thread wraps around a cylinder exactly 25 times. Calculate the circumference and the radius of the cylinder. Remember, as we said that this length of the thread wraps the cylinder 25 times, and 1 times is equal to the circumference of the cylinder. That means that 25 times is equal to 25 times the circumference of the cylinder. So if we want to calculate the circumference of the cylinder is equal to 550 centimeters, you divide by 25 times. 25 times is the number of turns. So to get 1 turn, which will be equal to the circumference of the cylinder. Also, to calculate the diameter, we rearrange this the equation of circumference which is equal to pi d. We rearrange it, and to get the diameter is equal to circumference divided by pi. So the circumference is the value you get of 1 turn, which is 550 divided by 25, then divided by pi. So this will give you the diameter. The radius is a half multiplied by the diameter of the cylinder. So the next part is estimation of length. So estimating length is important when precise measurement is not required. Estimation of length provides a quick assessment, therefore saving time and resources. So when you are going to buy a piece of land, before making the exact measurement, you can use your bare hands to estimate. That means that estimation of length, the value of a estimated length is close to the actual length. But the reason why we choose to estimate the length is to get a quick assessment of an object or a region. So we are going to conduct an experiment to estimate the height of the tree in a school compound. The apparatus that we only need 2 apparatus, that is a rod of length 2 meters and a meter rule, 100 centimeters meter rule. There is a spelling error here. This is supposed to be E, to be meter rule. So in this case we are going to use relational method. We are going to relate the height of the tree and the height of the rod, which will give a constant, and the length of the shadow of the tree to the length of the shadow of the rod, which will give the same constant. So if we cross multiply those values, we'll be able to get an estimated height of the tree. So the procedure involves holding the rod upright and measure its length. In our case, the rod is 2 meters. We measure the height of its shadow, so you must make sure that while doing that experiment there is the presence of sun. So, and also you must ensure that when you are measuring this length of the shadow of the rod, it should be in the same time when measuring the length of the shadow of the tree. This is because if the position of the sun changes, there will be high chances that you get incorrect measurements. So the third one is to measure the length of the shadow of the tree in the school compound. I propose that you should start from the stem, from where the tree starts, the stem of the tree, and you should measure midway at the middle part of the shadow to the peak of the tree. So that will give you the actual length of the shadow of the tree. So this is a picture. It will give you an illustration of how the experiment will look like. This is the height of the tree. So we will be relating it with the height of the rod. So the height of the tree, we denote it as h, small h, and add the subscript tree. And the height of the rod, we use small h and put the subscript rod. Then the length of the shadow of the tree, we use L, capital L, and the subscript tree, and the length of the shadow of the rod as L and the subscript rod. So if we divide length of the shadow of the tree and the length of the shadow of the rod, the value we get will be equal to the height of the tree we divide by height of the rod. So that is a relational method. We are going to use that method to estimate the height of the tree. So we will be using this formula. This is the formula that we'll be using. The height of the tree we divide by the height of the rod, will be equal to the length of the shadow of the tree we divide by the length of the shadow of the road. Remember, this one gives you a constant, and this constant is equal to the value we get here. That's why we equate. Also ensure that you don't interchange. The tree should be on the top and the road should be at the bottom. So this is the formula that we will be using to calculate. So let us look at the example. In an experiment to estimate the height of a tree at the school compound, the students recorded the following data. So the first data is the length of the shadow of the tree, which was found to be 1000 centimeters. Remember, it is easy to measure the length of the shadow of the tree because it is on the ground. The next data was the length of the shadow of the rod, which was found to be 200 centimeters, and the height of the rod, which was 100 centimeters. Now the students were in the process of calculating the height of the tree. Remember, the height of the tree is the unknown in this case. So we use the formula that we applied initially. That is the height of the tree, which is unknown. It is represented as x in this case, divided by the height of the rod, will be equal to the height of the shadow of the tree divided by the length of the shadow of the rod. So x divided by 100, remember 100 is the height of the rod, is equal to the length of the shadow of the tree. This one is 1000 divided by the length of the shadow of the rod. So the height of the tree is found to be 500 centimeters or 5 meters. So that is how we estimate the height of object. So the next aspect we're going to look under measurement 1 is area. So area is a derived quantity. Unlike length, area involves multiplication of different types of length. For instance, the rectangle, we calculate the area of rectangle by multiplying length times width. Remember, width is also a length. Therefore, multiplication of physical quantities gives you a derived quantity. Therefore, area is a derived quantity. So area is the measure of surface of an object. The SI unit of area is the square meter. The square meter. And also the square meter has its multiples and submultiples given below. So we have 1 square meter will be equal to 1000 square millimeter. Remember, 1000 millimeters is equals to 1 meter. So finding the square of 1000 millimeters is a million. So 1 square meter will be equal to a million square millimeters. 1 square meter gives you 10,000 square centimeters. This comes from 100 centimeters equal to 100 meters. If we find the square of both, we get 10,000 centimeters square, giving you 1 square meter. 1 square kilometers gives you a million square meters. This comes from 1,000 meters gives you 1 kilometers. Therefore, if you exercise, you can try. You are asked to express the following in square centimeters, and the first thing is to know how many square centimeters make 1 square kilometer. From there, you can cross multiply and find the value of 0.0027 in square centimeters, and also you can find 4.5 square meters in square centimeters. The second one requires you to express the following in the SI units. So given that is area, the SI unit of area is square meter. So that means that everything is supposed to be converted to square meter. So you convert 9,000 square centimeters to square meter and the rest. So the next aspect of measurement 2 is measuring the area of regularly shaped objects. The area of regularly shaped objects. So area of regularly shaped object is obtained using appropriate formula. So different regular shaped objects have different formulas for calculating their area. So let us look at the first one, is the rectangle. The rectangle has one side is longer than the other. So the area for calculating the rectangle is length times width. So you multiply these two lengths, the length and the width. A width is a special type of length. So if you multiply the two, you find the area of the rectangle. And also you must be careful with the units used. So if you are asked to calculate the area of the rectangle and convert to the SI units, meaning if it was in centimeters, you calculate the area, then you convert to square meters. The next shape is the circle. I hope everyone is aware of the circle. The circle is a simple regular object, so with a radius and a diameter. So calculating the area is simply pi r square, where r is the radius of the circle. I'm not going to explain that one so much because everyone is aware of calculating the area of the circle. The next one is the triangle. I know everyone is aware of the triangle. So it has a height and a base. So the area, calculating the area of the triangle involves using the following formula. That is a half base, that is the base, the lower length is the base, times the perpendicular height. Not any other height, but the perpendicular height. Remember, this is the hypotenuse and this is the height. This is the perpendicular height that is supposed to be used. The next one is the trapezium. The trapezium, as some section is a rectangle and some section is a triangle, you can either choose to split the two parts. The first one, you calculate the area of the rectangle, then you add to the area of the triangle, or you can use the following formula. The area is given by a half the sum of parallel sides. So this is the parallel side, this is A, is one of the parallel sides, and this is the another parallel side. From this point to this point, we multiply by the perpendicular height, so that one will give you the area of the trapezium. So the next one is the volume of irregular shaped surfaces. So in most cases we have irregular shaped objects like a piece of stone, and we need to calculate the area of that one, or another surface that is irregular. The first thing you do is that, let us first see how we can calculate those areas. So area of irregular shaped surface can be estimated by subdividing the surface into small equal squares and the area obtained as. So if you have a surface that is irregular, you place that one on a piece of a graph paper. The graph paper can give you equal squares, and the one square, if you measure with your ruler, you can see it is 1 centimeter. So the area of that box is 1 square centimeter. So if you divide that surface, that irregular surface, into those subsections, you can calculate the area as the number of complete squares plus the number of all incomplete squares divided by a half. A half is divided on the number of incomplete squares. So the sum will give you the area of an irregular shaped surface. So the next thing that we are going to look at is the volume. So the volume refers to the amount of space occupied by matter. We said matter is anything that occupies space and has mass. Matter can be air, solid, or liquid. So that space that matter takes is called volume. The volume or the amount of matter that can be accommodated in a given area. So that region is called the volume. So the volume is a derived quantity because it involves multiplication of basic physical quantity, which is length. The SI unit of volume is cubic meters. So the following are the multiples and submultiples of the cubic meter. So we have 100 centimeters making 1 meter. If we cube both sides, we get that 1 cubic centimeters equals to 1 cubic meter. The same applies to other subunits. Also, we have liters. So 1,000 liters is equal to 1 cubic meter. So in a box of 1 cubic meters can accommodate 1,000 liters. So this is an exercise that you can do. You convert each of the following to SI units. So we have 1,500,000,000 cubic centimeters. You convert it to cubic meters. Remember, when you are asked to convert to the SI unit, it means you convert to cubic meters. So liters, you base your calculation on this table. So you come to this table and see how many liters make 1 cubic meter, or how many cubic meters make 1 liters, and convert accordingly. Also, let us look at calculating the volume of regularly shaped objects. So we have different objects that are regular, and this object takes different formulas. So volume of regularly shaped objects are obtained by applying an appropriate formula, just like area. So we have a cuboid. A cuboid is a special type of a rectangle that is extended, so all sides are not equal. So to calculate the volume, we multiply length times breadth times height. All the 3 dimensions are special types of length, so it is length times breadth times height, and that one we calculate the volume of the cuboid. The next solid is the triangular prism. The triangular prism, we can calculate its volume by a half times cross-sectional area times length. A half base times height times length. Remember, a half base times height is the area of the triangle. And looking at this solid, we can cut many triangles from this solid, meaning the surface of the triangle is the cross-sectional area of this triangular prism. Therefore, the volume is calculated by a half times base times height, which is the area times the length of this solid. The next volume is the volume of the cylinder. It is calculated by cross-sectional area times height. So the cross-sectional area is the circular part with a radius, so it is pi r square times height. That gives you the volume of the cylinder. So the sphere, as you can see, it is almost circular, but it's not circular. So the volume is calculated by 4 divided by 3 pi r cubic. So the radius is cubed in this case. So that gives you the volume of the sphere. The next one is a cone. A cone has a base of a circular surface. So that is the base of a cone. So the volume is given by a third base area times height, and the height is the perpendicular height from this point upwards. It should be perpendicular to the radius of this circle. So it is a third pi r square multiplied by the height of the cone, the perpendicular height of the cone. That gives you the volume of that solid. So let us look at this exercise. A block of glass is 5 centimeters long, 4 centimeters thick, and 2.5 centimeters high. Calculate the volume. So a block, this one, as you can see, the dimensions are not the same. That means that solid is a cuboid. So, and the volume of a cuboid is given by from the previous notes, the volume of a cuboid is given by the length times the breadth times height. So if we come to our question, we will calculate our volume as this is, we assume this is the length, this is the breadth, and this is the height. So multiplying these three dimensions gives you the volume of the solid. So it is 5 centimeters. You multiply by 4 centimeters, you multiply by 2.5 centimeters, you get 50 cubic centimeter. There is an error here, it is supposed to be cubic centimeters, not square centimeters. Also, we can convert 50 cubic centimeters to cubic meters. We get 0.00050 cubic meters. So that is how we solve that question. Another one is find the volume of a triangular prism of base 6 centimeters, height 5 centimeters, and the length 12.0 centimeters. I think previously we saw the shape of a triangular prism. Let us go back and see how a triangular prism looks like. So this is how a triangular prism looks like. So we have its cross-sectional area as the triangular. So the volume is calculated by cross-sectional area times length, and the cross-sectional area is a half base times height, because the cross-sectional area is the triangle. So if we go to our question, we get that the prism has a base of 6 centimeters. This is the base of that triangular part, and the height, that is the height of the triangular part, and the length, this is the length of the prism. So the volume is calculated by area times the cross-sectional area times length, which is a half, times 6 centimeters. 6 centimeters is the base, and 5 centimeters is the height, and 12 centimeters is the length. This one gives you 180 cubic centimeters. We can also convert that one to SI units, and you get it is 0.001800 cubic meters. So measuring volumes of liquids. The next one is measuring volumes of liquids. So to measure the volume of liquids, you can use various tools depending on the quantity you need to measure. So depending on the quantity you need to measure, there are different tools you can use. The first one is using a container with cross-sectional area, and the container can be a square prism, a rectangular prism, or a cylinder. So the liquid is poured into the container, and the height of the liquid is measured. The first thing we must know is that the volume of water takes the volume of the container. That means that if we can be able to calculate the volume of the container, we can easily know the volume of the liquid. And the volume of the containers is calculated based on the formulas that we have discussed previously. So the volume of the liquid is calculated using the following formula. The volume of the liquid is given by the cross-sectional area of the container times the height of the liquid. So we can have the container and the water not reaching to the maximum height of the liquid. So the height where the water reached will be the height of the liquid. And if we multiply cross-sectional area times the height of that liquid, we get the volume of the liquid. So as you can see, this is the container, a cylindrical container where the liquid is placed, and this is the height of the liquid. So the volume is calculated by this cross-sectional area, which is the circular part, times the height. So it is pi r square times the height. That one gives you the volume of the liquid. Also, we can use another instrument. Using a suitable volume measuring apparatus. So there are a number of tools or instruments that are used to measure the accurate volumes of liquids. and they include the pipette, the burette, the volumetric flask, and the syringe. So these are the tools that are present in your laboratory that you can use to measure the accurate volumes of the liquids. So the pipette and the volumetric flask are used to measure the fixed volumes of liquids. Remember, we have different types of volumetric flasks. We have a volumetric flask marked 250. We have another one marked 500 cubic centimeters and another one marked 1000 cubic centimeters. So we can only measure the actual 250 centimeters, 500 cubic centimeters, or 1000 cubic centimeters. We cannot measure changing volumes in those two instruments. And the pipette only measures 25 cubic centimeters. But the burette and the syringe can be used to measure varying volumes of liquids. So let us look briefly at the burette. So this is the picture of the burette. The burette has a 0 mark at the top and the maximum point, which is 50 cubic centimeters, at the bottom. It has an opener where the required liquid or the desired liquid is released, and you can close after you have titrated the desired liquid. So the scale of the burette is marked such that the 0 mark is at the top and the maximum value mark is at the bottom. So if you release a certain volume of liquid, you just count from the top. So if you release the 25, you just count from the top, the empty part, until where the liquid, the meniscus of the liquid is. For example, water level in a burette is 24 cubic centimeters. If 100 drops of water falls from the burette and the average volume of one drop is 0.12 cubic centimeters, what is the final water level in the burette? Let us look at our picture of the burette. So we have a burette that was initially full of water. This water was released until this point, 24 cubic centimeters. So looking at our diagram, we have a 24 centimeters mark. This is where the level of water is, and at this 24 cubic centimeter mark, 100 drops of water is released. So it is released, so we are expecting a new level to be around here. So to find the final reading, we are required to find the final reading of the burette. So it is the initial volume, which is 24 cubic centimeters, plus the total volume of the 100 drops. So how do we calculate the total volume of 100 drops? We are told that one drop is equal to 0.12 cubic centimeters. So the volume of 100 drops of water is 100 drops, you multiply by 0.12 cubic centimeters. So, and if you add that value to 24 cubic centimeters, we get our final water level in the burette. So this is the solution. So volume of one drop is equals to 0.12 cubic centimeters. Volume of 100 drops will be equal to 100 drops. So there is no, it is not 1000, so there is an error here. So it is 100 drops of water, you multiply by the volume of each drop, which is 0.12 cubic centimeters, and this one will give you 12 cubic centimeters. So 12 cubic centimeters is the total volume of the 100 drops. So the initial level was 24 cubic centimeters. Therefore our final level will be 24 cubic centimeters plus the volume of the total water droplets, which will give you 36 cubic centimeters. So the final reading will be around here, 36 cubic centimeters. So measuring volumes of irregularly shaped objects. Measuring volumes of irregularly shaped objects. The method used in this case is displacement method. since it displaces some liquid when immersed. So when we have an object, we have an irregular shaped object, it does not have a regular shape. So meaning we cannot have the length, we cannot easily determine the length, the width, or the height. So we can use the displacement method where we have water in a calibrated container, for example a measuring cylinder, a bigger one. Then we immerse the object, the irregular object, and this method will use the displacement, the displacement principle, or the Archimedes principle, which states that the object will displace its volume of water. So the rise of volume of water in a beaker will be equal to the volume of the irregularly shaped object. So experiment, the first one is using a measuring cylinder. So these are the two measuring cylinders. As you can see, the first one, there is no object inside, we have the initial reading. No, this is the only one measuring cylinder where we have the initial volume, and the same measuring cylinder we have placed a stone. We assume this is a stone that is of irregular shape. So this stone, immersing this stone in this liquid, the level of water will rise. Now the rise in the level of water will be equal to the volume of the stone, meaning the volume of the stone will be equal to the final volume of the beaker, the final volume which involves the water plus the stone, minus the initial volume, which is the volume of water. That one will give you the volume of the stone. So the procedure is partly filling the measuring cylinder with water and note the volume 1. Tie the stone with a thread and lower it gently in the cylinder until it is fully submerged. Note the new reading of water. Now the volume 2 is the volume of water and the stone, but the volume 1 is just the volume of water before you immerse the stone. So the volume of the stone can be calculated as volume 2, you subtract volume 1. Volume 2, remember, it is the volume of water and the stone, and the volume 1 is the volume of the water only. So this is an example. If a stone of volume 6 cubic centimeter is inserted to sink in water in above cylinder, what will be the new level? So the new level is initial level plus the volume of the stone. So the initial volume was the initial volume. This is now the volume, 36 cubic centimeter. Remember, we let us assume the initial volume is 33 cubic centimeters, and a stone of volume 6 cubic centimeters is inserted. I forgot to add the image of that, the image of that beaker. So the beaker has an initial volume of 33 cubic centimeters. That is water alone. We have said if a stone of volume 6 cubic centimeters is inserted to sink in water, so what will be the new reading? The new reading will be equal to the initial level plus volume of the stone. So which is 33 cubic centimeters plus 6 cubic centimeters, which will give you 39 cubic centimeters. That will be the final reading, which will be equal to the volume of the water plus the volume of the stone. The second method is using a Eureka can. Now a Eureka can is a container used to demonstrate the principle of displacement and Archimedes principle. So the Eureka can has a spout on the top. I'm going to show you a picture shortly. So we will measure the volume of an irregular object following Archimedes principle, which states that the volume of an object submerged in a fluid is equal to the volume of the liquid that object displaces. So here is how it works. This is how the Eureka can works. You fill the Eureka can with water until it overflows. You wait, it overflows through the spout. I'm going to show you the picture shortly. Wait for the water to stop coming out of the spout. Place the measuring cylinder under the spout. The measuring cylinder will be measuring the volume of the irregular object that you're going to immerse. Tie the stone with a thread and lower it gently into water until it is fully submerged. collect the water coming out of the spot using a measuring cylinder. So this is a picture. This is a spot. You add water until it overflows. If you allow it to cool down, this will be the spot, at the edge of the spot. This will be where water is. This means that if you place any object, that object will displace this water upwards, and this water will flow. That's why we have this measuring cylinder, to measure the volume of water that is overflowing due to immersion of an object. And in this case, our object is an irregular shaped object. So we place, the first thing you do is to place the empty measuring cylinder. Then you place a tied stone inside this water. This stone will displace water that is equal to the water measured in this measuring cylinder. So results, the volume of water collected in the measuring cylinder is the volume of the stone. So this volume, if you read its value, this value will be equal to the volume of the stone. Now let us look at another basic physical quantity, that is mass. Mass, you are all aware of what mass is. Mass is the quantity of matter in a substance. The SI unit of mass is in kilograms, small k, small g. So mass is measured in kilograms. So mass is measured using instruments. There is an error here. There is a grammatical error. It is supposed to be measured. So mass is measured in using beam balance, top balance, and among other measurements. So we have different multiples and submultiples of mass, same like other quantities such as area. For mass also we have some multiples and submultiples. We have 1 kg is equals to 1,000 grams. 1 ton is equal to 1,000 kilograms. 1 gram is equals to 1,000 milligrams, and 1 kilogram is equals to 1,000,000 milligrams. So you can interconvert within the multiples and submultiples. So an exercise involving the multiples and submultiples of mass, and I'm going to give you the answers to that exercise. You convert 20 grams into kilograms, 100 grams into kilograms, 340 kilograms into tons, 39.6 milligrams into kilograms. So you follow this table here. You follow these multiples and submultiples. You know how many kilograms make 1 ton, or how many grams make 1 kilogram, and then convert accordingly. So these are the answers. If we calculate, we get 20 grams is equal to 0.020 kilograms. 100 grams into kilograms is equals to 0.100 kilograms. 340 kilograms into tons is equal to 0.340 tons. 39.6 milligrams into kilograms is equal to 0.0000396 kilograms. Now let us look at density. Density is the mass per unit volume of a substance. So density is equals to mass divided by volume. That means that density is a derived quantity because it has involved a division and a multiplication. Volume is given by multiplication of length, and density is given by division of mass and the volume. So density is a derived quantity. The SI unit, the SI unit of density comes from mass and volume. So it is kilogram per cubic per cubic meter. The symbol is rho. This one is P. This one, because I did not find the correct symbol, so I use just P, but it is not the right one. So the density is denoted by a Greek letter rho. That one you can find it in your textbooks. So the formula of density is given by mass divided by volume. The formula assumes that the mixture is uniform and the components are well mixed. Keep in mind that if the mixture undergoes a chemical reaction, or if there are significant changes in temperature or pressure, you may need to consider those factors in your density calculation. So the SI unit of density, as we said, is kilogram per cubic meter, and 1 gram per cubic centimeters is equal to 1000 kilograms per cubic meter. Let us do an exercise. Determine the density in kilogram per cubic meter of a solid whose mass is 40 grams and whose dimensions in centimeters are 3 by 40 by 3. So we just apply the first thing, we apply the formula. This one is mass divided by volume. We already have the mass. We make sure we can convert the mass to kilograms or just leave it there. And also these are dimensions, the 3 dimensions. So because we need the volume, we will multiply these 3 dimensions and we get our answer in cubic centimeters. Therefore our density will be equal to mass divided by volume, which is 40, divided by the product of these 3 dimensions. So volume is given by length times width times height, which is 30 times 3 times 4, which is 360 cubic centimeters. Density is given by mass divided by volume, which is equals to 40 grams divided by 360 cubic centimeters, and this one will give you 0.1111 grams per cubic. There is an error here. This is supposed to be per cubic centimeters. Also we can convert to kilogram to the SI units. We just multiply by 1000, then we get is equals to, the density will be equal to 111.1 kilograms per cubic meter. Now let us look at the density bottle. The density bottle is a small glass bottle fitted with a glass stopper which has a hole through which excess liquid flows out. So there are a number of precautions when you are using a density bottle. The first one is that the density bottle should be held by the neck when wiping it clean. So because if you touch it at the base, there are chances that the liquid in that density bottle will expand, and that one will result into inaccuracies. The second one is that the outside of the bottle must be wiped carefully. The last one is that there should be no air bubbles when the bottle is filled with the liquid. This is because we just need the accurate volume of the liquid. So if there will be air bubbles, they will take some volume, therefore we cannot be able to obtain the actual volume of the bottle. So the note, it is important to note that the density bottle can be used to calculate the density, to measure the density of both the liquid and the solid objects. So let us look at the exercise that involves using the density bottle. The mass of a density bottle is 20 grams when empty. So this is the mass of the bottle when empty, 70 grams when full of water. I forgot this one. 70 grams when full of water, and 55 grams when full of a second liquid X. There is a second liquid, this liquid here, second liquid X. Calculate the density of the liquid X, given that the density of water is 1 grams per cubic centimeter. So in this case, we are going to find the mass of water. So when empty is 20. When full of water, it is 70 grams. So the mass of water is given by what? So the mass of empty bottle is 20. The mass of bottle plus water is 70 grams, meaning the mass of water is 70 minus 20, which is 50 grams. The volume of the density bottle is given by mass divided by density. Remember, we have the density of water, meaning the density of water will be given by, this is the density of water, not the density of the water bottle. So we'll be given mass divided by density, which is 50 grams divided by 1 gram per cubic centimeter, and we get the density of water in that bottle to be 50 cubic centimeters. Now let us look at the mass of the bottle plus liquid X is 55 grams. So the mass of liquid X is 55 grams minus 20, which is the mass of the empty bottle, and that one will give us 35 grams. So 35 grams is the mass of liquid X. So the volume of liquid is equal to the volume of the density bottle. Remember, the volume of water, we said the liquid takes the volume of the container. So if the volume of water was 50 cubic centimeters, it means that that is the volume of the density bottle, and that will be also the same volume of liquid X, because liquid X will also take the space of the bottle. So the density of liquid X will be therefore equal to mass divided by volume. Remember, the volume is 50. So the density of liquid X is calculated by mass divided by volume, which is 35 divided by 50. 50 is the volume of the density bottle. So the answer will be 0.7 grams per cubic centimeters. If you want to convert it to the SI units, you multiply by 1000, then you get the density of liquid X to be 700 kilograms per cubic meter. So you can go and try this one. A density bottle has a mass of 17.5 when empty. When full of water, its mass is 37.5 grams. When full of liquid X, its mass is 35 grams. If the density of water is 1000 kilograms per cubic meter, find the density of liquid X. You just apply the same concept and the same procedure that we have done here. So let us look at the density of the mixture. A mixture is obtained by putting two or more substances such that they do not react with each other. The density of mixture is calculated by the total mass of the mixture divided by the total volume of the mixture. So you must have the total mass and the volume. So mass should be on the top and volume at the bottom. So let us do this example. A mixture consists of 40 cubic centimeters of water and 60 cubic centimeters of liquid X. If the densities of water and liquid X are 1 gram per cubic centimeters and 0.8 grams per cubic centimeters respectively, calculate the density of the mixture. So we have two liquids here, water with 40 cubic centimeters, liquid X with 60 cubic centimeters. So we have the volume. So the total volumes, we can have it by adding 40 plus 60, but we need the mass. So how do we calculate the mass? We have the densities, their respective densities. Therefore we just calculate the mass of an individual liquid, then we add those masses. So mass of water will be equal to the density of water times volume of water. The density of water is 1 gram per cubic centimeter. It's given. You multiply by its volume, which is 40. We get 40 grams. The mass of liquid X is given by the density of liquid X. You multiply by the volume of liquid X, which is 0.8. It is given here. 0.8 times 6, which is 48 grams. Now the density of the mixture is equal to the total mass, which is mass of water plus mass of liquid X plus the total volumes, which is 40 plus 48. 40 is the mass of water, 48 is the mass of liquid X divided by their respective volumes, which is 88 grams is the total mass and 100 cubic centimeters is the total volume, and the density of the mixture will be 0.880 grams per cubic centimeters. So thank you all for being part of today's presentation on measurement. Understanding the complexities of measurement in physics is important, and your participation promotes the learning experience. If you have any concerns, thoughts, feel free, and questions, feel free to comment on the comment section. And these are my official contact. In case of any issue, you can reach me through these contacts.